Lesson 24: Scaling up with reducer and context. 1. Combining a reducer with context. Hello everyone. Today I'll walk you through how we can scale up state management in React applications by combining a reducer with context. We'll explore why this pattern becomes valuable as the component tree grows deeper. In our journey we'll see how we can avoid cumbersome prop drilling, how we can provide state and dispatch logic across many components, and how we can organize our logic into dedicated files for better maintainability. In simpler applications, you may have a component that holds state and provides some handlers. That works fine at smaller scale. But when many components, perhaps tens or hundreds, lie in between the top-level provider and deeply nested consumers, passing state and handler functions through every layer of the hierarchy becomes tedious, error-prone, and leads to components concerned more with plumbing than with their own logic. That's where combining a reducer, to centralize update logic, and context, to distribute state and dispatch, shows its power. 1.1 Step 1. Create the context. The first step is to define context objects for the parts of state you wish to share. Specifically, one context for the current state value, and another context for the dispatch function, or update mechanism, produced by the reducer. By doing so, you separate the concern of reading from the concern of updating, and you make them independently accessible to downstream components. Creating these contexts in a separate file is useful. It abstracts away the details of how the state and update logic are provided, and makes the usage cleaner in components. 1.2 Step 2. Put state and dispatch into context. Once you have the reducer logic that manages state updates and you have your context objects, the next step is to wrap your component tree in providers for those contexts. You run the reducer to obtain a state value and a dispatch function, and then you provide these through the respective contexts. In effect, this makes both the current state and the mechanism to act on that state available to all components underneath. By doing this, you're liberating your nested components from needing to receive props for state or event handlers. They can instead read from context. 1.3 Step 3. Use context anywhere in the tree. With the providers in place, any component in the tree can now tap into the context. If a component needs to read the current shared state, it imports and uses the state context. If a component needs to update, it uses the dispatch context. This means you no longer have to thread properties, state and handlers, through each level of the component tree. Each consumer can independently subscribe to context and use the part it needs, making the architecture much cleaner and more scalable. 2. Moving all wiring into a single file. Once the pattern of reducer plus context is working, a further step toward cleanliness is to move both the reducer logic and the context definitions into a single dedicated module. This module can export a provider component that encapsulates the reducer invocation and context providers, accepting children and wrapping them appropriately. Custom hooks, or functions, that hide the detail of context consumption, for example, a hook to get the state, another to get the dispatch. By relocating this wiring into one place, you declutter your top-level component and your intermediate ones. They simply use the provider module. Your display components focus only on rendering or handling user interactions, and are not burdened with how state is connected. 3. Recap. To summarize our discussion, combining a reducer with context allows any component in a subtree to both read and update state that lives above them. The key steps are: 1. Create two contexts, one for state, one for dispatch. 2. Provide both from the component that uses the reducer. 3. Consume either as needed in downstream components. For improved code organization, move context definitions, the reducer, the provider component, and custom hooks into a separate file. This centralizes your state management logic and keeps your component tree clean. As your application grows, you may create multiple such context reducer pairs, each carefully scoped to a piece of shared state or feature domain. This pattern scales effectively without excessive prop drilling or coupling. In conclusion, when you face growing complexity in a React application, many components, nested hierarchies, shared state across distant parts of the tree, this pattern of reducer plus context gives you a robust architecture, centralized update logic, flexible access to shared state, and decoupled